Okay, morning everyone. We're just going to go through the exercise on inequalities on page 89 of your Mind-Born Maths calculus book. Okay, so our first step always in questions like this is to make sure we get everything on the left-hand side. So I get 1 over, remember the key idea is you cannot multiply by a variable. Okay, can't multiply by a variable because you don't know whether that variable is positive or negative. So you don't know then whether the direction of the inequality has changed. So you cannot multiply by a variable. Okay, because if you multiply, if the variable was negative, the direction of the inequality would change, and if it's positive, it would stay the same. So that is your fundamental idea, and that's how they differ from equations. Equations, you can multiply by the variable, okay, because the sign, whether it's positive or negative, doesn't matter. So you can get rid of the denominator. You can never get rid of the denominator, okay, from an inequality if that's a variable. If it's a constant, you can. If it's a variable, you cannot. So 1 over y minus 2 minus 1 over y plus 2 minus 1 over 8 is greater than or equal to 0. So my common denominator is 8y minus 2y plus 2. Then you say to yourself, what am I timesing by? Okay, so to get from here to here, you're timesing by 8 and y plus 2. Okay, so you're going to get 8 times y plus 2. Over here, you're timesing by 8 and y minus 2. So it's going to be times 8 and y minus 2. And over here, you're timesing by y plus 2 and y minus 2. So it's minus y plus 2, y minus 2. Okay, you can get rid of that 8 in the denominator now. Okay, so in our next line, I'm going to get rid of that. You can keep it there, it doesn't matter. Okay, but you can time, what you're doing is you're timesing both sides of the inequality by 8. Okay, but you can't get rid of the y minus 2, y plus 2 because you don't know whether those are positive or negative. Okay, so now we're going to times up the top, and I get 8y plus 16. Careful of your signs here. Minus 8y plus 16. Okay, and then you're going to get y squared. This is going to become y squared minus 4. But when I distribute the negative, it becomes minus y squared plus 4. Okay, all over y minus 2y plus 2. And that's bigger than or equal to 0. Okay, if we add the like terms in the numerator, 8y minus 8y disappears. You're left with negative y squared. Okay, then you're going to have 16 plus 16 is 32 plus 4 is 36. Over y minus 2y plus 2. Remember, I got rid of the 8, and the direction of the inequality won't change because it was positive 8. Okay, is bigger than or equal to 0. I wouldn't want to work with that. I would like to make the coefficient of y squared positive, in which case I'm dividing by a negative. So you get y squared minus 36. You don't divide the top and the bottom by the negative, otherwise you've done nothing. Okay, but when you divide by a negative, the direction of the inequality changes. So you get y squared minus 36 over y minus 2y plus 2. Then that's going to factorize to y minus 6 y plus 6 over y minus 2y plus 2. And I'm looking now for where it's less than or equal to 0. So now we have 4 critical values. My critical values are going to be when y is equal to 6, minus 6, 2, minus 2. Okay, so we're going to put those onto the number line. When I put those onto the number line, I get minus 6, minus 2, 2, and 6. Okay, when x is equal to when y is equal to 6 and minus 6, it's in the numerator. So overall, it's going to be 0. Okay. But when y is equal to 2 and minus 2, those are in the denominator, so the whole thing's going to be undefined. So I always put those up there. Then I get the first thing right, and then there's no perfect squares, so everything's going to alternate. So if I choose, I always circle these so that I don't get confused where my negatives are. Okay, if I choose a number to the left of negative 6, like negative 10, then this factor would be negative. Negative 10 plus 6 would still be negative. Negative 10 minus 2 would be negative. Negative 10 plus 2 would be negative. So you're going to get negative times a negative is a positive, and a negative negative, 4 negatives make a positive, so overall you get a positive. Remember, you're always going to read off the top line what's going on. So that's where your answers are going to be positive. Okay, then because there's nothing all squared, if there's something all squared, like y minus 2 all squared, then you've got to be really careful because your things aren't going to alternate. But if there's nothing like that, okay, make sure you get the first thing right, and then what I do is I just go positive, negative, positive, negative, positive. They'll always alternate around your critical values. You want to go check them all if you want to, but you don't really, it's going to take a lot of time. Okay, the question says, what am I looking for? You always look at the last line before you do your number line. I'm looking for where I get negative answers. So you're going to get negative answers, okay, over here. Okay, you can include naught because it says less than and equal to naught. So you're going to include negative 6, okay, but you can't include that. Okay, so I do my answer on the number line. I can't include 2, okay, but I can include 6. So there's your regions where you're going to get negative answers, okay, and so your final answer, okay, you've got a choice now. You can write it as an inequality or an interval notation. If you write it as an inequality, it's going to be x is greater than equal, arrows way to the left, negative 6 less than 2, or x is greater than 2, less than or equal to 6. Okay, you've got to get those signs of those inequalities right. If you write an interval notation, you're going to write x goes from square bracket minus 6 to 2, or from round bracket to up to 6. Okay, right, and there is your solution for number 19. Or something like that's probably worth about 8 or 9 marks. Okay, key ideas: get everything to the left. You can get rid of constants. Okay, you can't get rid of variables. Okay, add like terms, factorize. You divide by negative, the direction changes. Get your first region really right. If there's nothing all squared, you can just alternate and read off your solution. Okay, righty. So that was that one over there. If you haven't got it down, press pause and carry on. Right, the next one is, don't play up with me, Paul. This 22, and you've got 6 over x plus 1 over 2x minus 3 squared is greater than or equal to 1. Okay, so now, okay, you're going to move the 1 to the other side. That's going to be your first step. So you're going to get 6x plus 1 over 2x minus 3 squared, okay, minus 1 is greater than or equal to 0. So now your common denominator is 2x minus 3 squared, that's over 1. Okay, then I'm going to have, this is going to stay the same, so that's going to be 6x plus 1. Then I've got a minus sign, okay, and then I times the bottom by 2x minus 3 squared, so I've got to times the top by 2x minus 3 squared. Okay, right, you're going to leave the denominator like it is. Okay, so you're going to get therefore, okay, 2x minus 3 squared. Okay, at the top I'm going to have 6x plus 1. 2x all squared is 4x squared, but I'm timesing everything by a negative after I've squared out. So it's going to be minus 4x squared. 2x times negative 3 is negative 6x, times 2 is negative 12x, times by negative makes it plus 12x. Minus 3 squared is positive 9, times by negative is negative 9, which is greater than or equal to 0. Right, then I'm going to add like terms at the top. If I add my like terms, I'm going to get minus 4x squared. Okay, plus 12x plus 6x is plus 18x. Okay, and 1 minus 9 is minus 8. Okay, all over 2x minus 3 squared. And we want to know whether that's bigger than or equal to 0. Well, to make my life easier, I'm going to divide the numerator by negative 2. If I divide the numerator by negative 2, I get 2x. Remember that the direction of the inequality is going to change. You don't touch the bottom, otherwise you haven't done anything. Divide the top by negative 2, you get 2x squared minus 9x minus 4 is less than or equal to 0. Now, if you suck at factorizing trinomials, okay, just go use your calculator, your silver calculators, or the white ones. Use your equation mode, trinomial, factorize it, get your solutions, and work backwards. But that should factorize to 2x so you're going to have 2x and x. You want to end up with minus 9. I made a mistake. 2x squared minus, if I divide by a negative, this should have become plus 4, sorry. When I divide by a negative, okay, negative 2, 2x squared minus 9x plus 4, that's right. So it's going to be 2x minus 4 over there, minus 1 here, check it, 2x squared minus 8x minus 9x plus 4. Okay, so now what are my critical values? Well, what makes 2x minus 1 naught? Well, that'll be when x is equal to a half. What makes 2x minus 3 equal to naught? Okay, that'll be when 2x minus 3 is equal to naught. X is going to be equal to 3 over 2. Okay, so your critical values are going to be a half, 4, and 2x minus 3 gave us 3 over 2. So those are your 3 critical values. Okay, you've got to put those in the right order in the number line. So if I have my number line, I've got a half is the smallest, 3 over 2 is the next one, and I've got 4. Okay, right, now be careful, because this 2x minus 3 squared makes life a bit interesting, because the key idea is if you square anything, it's going to be positive. Okay, so at the bottom, okay, if I look at my individual terms, everything's going to be positive at the bottom. Okay, so basically, it's not going to change signs around 3 over 2, okay, because that's always positive. And at the bottom over here, I'm going to have positive. Okay, sorry, it's all just behaving. Right. Then when x is equal to a half itself, okay, so if I look at a number smaller than a half, like naught, okay, then I'm going to have negative over here, okay, negative there. Yep. And overall, I'm going to have a negative times a negative, which is a positive. So this is where my answers are coming from. That's the final answer, which is positive. Okay. When x is equal to a half itself, okay, it's at the top, so that'll be naught. Okay. If I choose a number between a half and 3 over 2, like 1, okay, then you're going to get in this region over here, 1 would be positive, negative, so it'll alternate there, so that's going to be negative. Now, just to show you, when x is equal to 3 over 2, first of all, the whole thing is undefined at that point. Okay, but now it's not going to change signs around 3 over 2. So this, I tell you, it's going to be negative, but I'll just show you why. Okay, because now around 3 over 2, okay, so if x was equal between 3 over 2 and 4, which is 1.5 and 4, so if x is 2, okay, the top factor there would be positive, the first one, but this factor here would still be positive over here. Okay. So this would still be positive. So overall, hang on. Sorry, that would be negative still. Apologies. Okay, so that would be negative. Come on. So it would be positive, 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 negative. I did it again. Okay, so that's going to still be negative in that region over there. Okay, so it hasn't changed as we expected. It hasn't changed around the critical value that goes with the square. So it's negative, negative. When x is equal to 4, it's going to be naught. And when x is bigger than 4, if you sub it in, well, it will be positive, positive. So you don't have to ever show this bottom line over here. Okay, but if you don't, make sure you get the first thing right. And remember that if you've got a perfect square, it's going to be the same sign, positive or negative, either side of where the perfect square is. Okay, so you're looking for answers where you're going to get negative solutions. We're looking for where I'm going to get negative solutions. So where do you get negative solutions? Over here. And then you get a gap, and over here, when x is a half or x is equal to 4, we can include those points, so that's a solid. So your answer is here in orange. Okay, how do we write that answer? Well, if you have an inequality, you can say x is greater than or equal to a half, okay, less than 3 over 2, or okay, or x is greater than 3 over 2, less than or equal to 4. In internal notation, I could say x goes from a half square bracket up to 3 over 2 round bracket, or x goes from 3 over 2 up to 4. Okay, so be careful. Okay, everything to the left-hand side. Simplify, same process over and over again. If you divide by negative, direction of the inequality changes. If you can't factorize those, use your silver calculators. Okay, around the square, the signs do not alternate. They'll both be negative. Okay, So watch out for that. Okay, and that is number 22. Press pause if you haven't got it down. Okay, and make sure you've got it. Okay. Right. The next one, question 23. You've got x minus 3 cubed over x plus 1 divided by x minus 3. Now, guys, those are identical. So you can divide out. You've just got to remember, after you divide, that x cannot be 3, because in the original question, you've got x minus 3 at the bottom. Okay, so x cannot be 3. You're solving the original question. Even though we're going to simplify, you've got to remember this. X cannot be equal to 3. Okay, so I'm going to divide, and just like x squared divided by x is equal to x cubed divided by x is equal to x squared, and here you'd say x cannot be naught. Okay, same logic here. X minus 3 cubed over x minus 3 is going to leave us with x minus 3 squared. You can do this. In fact, I would do it. Okay, over x plus 1. Okay, because anything to the power of 3 divided by itself gives you something to the power of 2 is less than equal to 0, but you must make a note, x cannot be 3. Okay, because of that original question. So now, my critical values are going to be 3 and negative 1. Okay, so now on the number line, okay, we're going to have critical values at negative 1, critical values at 3. Okay, be careful, it's not going to alternate around this point. So for example, when x is equal to negative 1, it's going to be naught there, but remember when x is equal to 3, because of this restriction, x cannot be 3, so it's undefined because of this original bit over here, right? If you chose a number smaller than negative 1, like negative 10, anything squared is going to be positive. Okay, if you subbed it in, but that's going to be negative, so you're going to get negative. It will alternate around this, so you should end up with a positive. Until you're going to end up with negative, positive. Around 3, there's not going to be a change, so that's still going to be positive. But just to show you, pick a number between negative 1 and 3, like naught. This term of bracket over here is still positive. Okay, and that's now positive, so it's positive overall. And if x is bigger than 3, like 10, that first thing is still positive, and that's still positive. So we end up with, here are your answers. What's the question asking? They want to know where we get answers which are negative or naught. Where does that happen? Okay, well, I get negative answers over here, and they can be naught. So I can include negative 1, and it's to the left. And that's the only region where you get positive answers. So that's not that interesting, actually. Okay, so your answer is just going to be, okay, x is less than equal to negative 1. If it was me, I would have made this question, where is this bigger than equal to naught? Okay, and where is it going to be bigger than naught? How would you write your answer? Well, it's going to be here. Is it going to be bigger than equal to naught? X can be negative 1. So that would be your region over there. And you'd write x goes from, so it would be bigger than naught if x goes from negative 1 to 3. This wasn't the question. The question, so the answer for your question was that one over there, from negative 1 to 3, or from round bracket 3, and then again from 3 to infinity. Okay. Right, so that's your answer for 23. X minus 3 squared x plus 1 is less than equal to 0. Okay, so your answer that the question we were doing, where's the negative? Just to the left of negative 1. Okay. So if you sub the negative 10, that'll be negative. That'll be negative. That'll be negative. The whole thing would be negative. All right, guys, that's 23. Okay, press pause if you haven't got it. The next one is B, question 6. Okay, wrote it like a twang. And I want to know where this over here is less than or equal to 0. X squared plus 4 over x squared minus 4. Okay, over 3 minus x. Where is that going to be less than or equal to 0? That's a 4 over there. The key thing here, guys, is that x squared plus 4, no matter what your value of x is, x squared plus 4 is always going to be positive because x squared is always greater than 0. greater than or equal to 0. So x squared plus 4 must definitely be bigger than 0, not even bigger than or equal to, bigger than 0. Think of the parabola x squared plus 4. That's always above the x-axis. It's got no critical values. It's got no x-intercept. So this thing over here is always going to be positive. We know for sure that it's positive. Okay. And because this is positive, we don't have to worry about it being a variable almost. Okay. It acts like a constant because it's always positive. So I can get rid of that x squared plus 4 straight away because this is always positive. The problem why we can't normally get rid of variables is because we don't know whether they're positive or negative. Okay, so that is always going to be positive. Okay. Right, so in this one over here, okay, x squared plus 4 over x squared minus 4, 3 minus x. Okay. Okay, right, I have to think of something. Just one thing, guys, in the previous one, you're not really dividing by a variable, you're cancelling. Okay, there's a difference. Okay, so cancelling and just dividing to get rid of one thing. Okay, so in that one over there, we kind of cancelled out the x minus 3. We weren't really dividing, we were just cancelling them out. Okay, so that's why we don't have to worry because that'd be exactly the same side. So essentially you're dividing by a positive. Okay, even if they're both negatives, two negatives together would make it positive. Right, so that's always positive. So I'm going to rewrite this question. Okay, get rid of the x squared plus 4. So because it's always positive, I can get rid of it. Okay, x squared minus 4, this thing over here, I'm going to rewrite as x minus 2x plus 2. Okay, and we're just going to leave it as 3 minus x at the bottom. You could divide out if you wanted to, but you don't have to. And I want to know whether that's less than or equal to 0. So if we keep it in this form, your critical values are going to be 2, negative 2. What makes this thing naught is if x is equal to 3. So on the number line, we're going to have minus 2, 2, and 3. Okay, when x is equal to 2 and minus 2, the whole thing will be 0. But when x is equal to 3, it's going to be undefined. Okay. If I choose a number, now you need to be careful. Pick a number to the left of negative 2. And sub it in, like negative 20. Negative 20 minus 2 will be minus 22. Negative 20 plus 2 will also be a minus. But 3 minus minus 20 will become a plus. Okay, so you're going to get a minus minus plus, which makes a positive overall. Okay, then there are no perfect squares. Okay, so because there are no perfect squares, there's nothing all squared like this. Okay, we know they're going to alternate, so it's going to go, okay, your answers then are going to be positive, negative, positive, negative. The question we asked is where is it less than, or we want to know where you're going to get negative answers. So I'm going to get negative answers over here in this region. Again, it is less than or equal to, so I can include the n numbers. I can't include 3 because it's undefined. So there in green is your answer on the number line. How do I write that? The final answer is going to be x is bigger than or equal to negative 2, less than or equal to 2, or x is bigger than 3. If you don't like, you don't have to write both languages. Either pick inequality or interval notation. If I use interval notation, we're going to have x goes from square bracket minus 2 up to 2, or from 3 to infinity. Okay, so remember, if it's x squared plus 4, okay, that thing is always positive. Okay, if you put x, if you went into your equation mode and you entered x squared plus 4, what would happen is you get imaginary answers, then I would come up on your screen. And if you get that, it means that there's no critical values that go with that. We're going to do one like that now. Right, so there's your answer for B, question 6. Okay, press pause if you haven't finished it, and make sure you comprehend what we just did. Right. Okay, the next one is question 8. And here you've got x squared is greater than or equal to minus 1 over x. Well, with inequalities, you can't get rid of that x at the bottom. So the first thing we're going to do is move it to the other side. So I get x squared plus 1 over x. You cannot ignore the naught. You've got to write that naught in. Okay, now you want a common denominator. That was over 1. So your common denominator is going to be x. I times the bottom by x and must times the top by x. So you get x cubed plus 1 is bigger than or equal to 0. Now, if you remember how to factorize perfect cubes, okay, you're going to get x plus 1. You take the cube roots of both of the originals, factorizing this. It's going to be all over x. Then you square your first term, so it becomes x squared. You times them together, you change the sign, which is negative x, and you get plus 1, which is bigger than or equal to 0. Now, when you factorize a perfect cube, okay, this trinomial that you're left with, okay, can never be factorized. It's got no critical values. If you go into your equation mode of your calculator, so quickly get out your silver calculators, what's going to happen is you see you're going to get, okay, no solutions here. So if I go into my calculator mode, equation, number 3, ax squared, I enter a is 1, I enter b is negative 1, I enter c is 1, equals, what happens is your answers, I've got a half plus root 3 over 2i. Check that. Okay, that means that this is some parabola which will have no x-intercepts, because your calculator, when you solve a quadratic, it's giving you the x-intercept. So this is telling you it's never going to cut the x-axis, and it's a positive one, so it's always going to be above that, right? Okay, another one is minus 1 minus 3 root 2i. So this, again, has no critical values. Okay, and once again, it's because it's positive, it has no x-intercepts. It means that the y, no matter what x value you put into this thing over here, any x value, negative 1,000, x value, play around with it if you want to, put in negative 1,000 into this quadratic, okay, put in 1,000, doesn't matter what you put in, okay, there's no critical values, and it's always going to be, what comes out of this quadratic is that it's always going to be positive. And again, because I know for sure that's definitely positive, okay, no matter what the value of x, I can divide by that. We know it's positive, the direction won't change, and I can get rid of it. So I'm essentially going to be left with x plus 1 over x. I've divided both sides by this. I know I can do it because that's always positive. Okay, and you're left with x plus 1 over x is greater than or equal to 0. So now the question looks a lot easier. I've just got to solve this. When I solve that, my critical values are going to be negative 1 and 0. Okay, so I'm going to have negative 1, I'm going to have 0. Okay, when x is negative 1, the whole thing's going to be 0, but when x is 0, the thing's going to be undefined. If I choose a number smaller than negative 1, okay, like negative 10, and I sub it into there, it will be negative. That will also be negative. Negative divided by negative is going to be a positive. You can check, it'll alternate because there's no perfect squares. So it's going to be positive, negative, positive. The question said, where do I get answers which are positive? And I get positive answers, positive or 0, so I can include that and to the left, but I can't include that and it's to the right. So your solution as an inequality will be x is less than or equal to negative 1 or x is greater than 0. If you prefer interval notation, it's going to be x goes from negative infinity to negative 1 or x goes from 0, not including 0, to infinity. Okay, so just remember, when you factorize a cubic, the quadratic you're left with, okay, will have no solutions. Get comfortable with the equation mode of your calculator. If your equation mode of your calculator comes up with imaginary numbers, it means there's no critical values. It means that thing's always positive. Okay, press pause if you haven't got that, get that done. Right, so question 10, you've got x cubed is greater than 1 over x. Okay, so again, we're going to get everything to one side of the equation. And you get x cubed minus 1 over x, I'm going to make that over 1, is greater than 0. So your common denominator is x. Okay, this I times the bottom by x, I must times the top by x, so you're going to get x to the 4 minus 1 is bigger than 0. That factorizes to x squared minus 1, x squared plus 1, all over x is greater than 0. Okay, and now x squared minus 1, x squared plus 1. X squared minus 1 can be factorized to x minus 1, x plus 1. The x at the bottom is still fine, but x squared plus 1 is an irreducible quadratic. If you put that into your calculator, you get no solutions. Remember, it's a parabola that looks like this. No matter what x values you put in, this whole thing is always going to be positive. It's got no critical values. So we know it's always positive, so we can divide by it, unlike most variables. Okay, and when you divide by x squared plus 1, the effect is to get rid of it. Okay, and I'm left with x minus 1, x plus 1 over x is greater than 0. So your critical values are going to be 1, -1, and 0. Let's put those onto the number line in the right order: -1, 0, and 1. Okay, we're looking for where you're going to get positive answers. It's just greater than, so we can't include it. We can't include naught. Okay, so because I can't include naught, well, here at -1, it would be naught. At naught, it would be undefined. Okay, and at 1, it would also be naught. Okay, but no matter what, because it's greater than, we're not going to include any endpoints because we can't include naught as part of my solution. If I subbed in a number smaller than -1, like -10, each individual factor, circle those so we don't get confused, it would be negative over a negative, okay, which is going to give us a negative. There are no perfect squares, so it'll alternate. Okay, we're looking for, we get positive answers. Okay, I get positive answers over here and over here. And remember, because it's greater than naught, not greater than equal to, I can't include any points. So there is my solution on the number line. How do I write that out? X is greater than -1, less than naught, or x is greater than 1. And then I'm going to say x goes from -1 to naught, round brackets, if you prefer this language, or from 1 to infinity. Right, that's question 10. Okay, please pause and get that down, if that makes sense. Okay. Right, and last one, question 16. Okay, I think that's the last one, yeah. Okay, you've got absolute value of x minus 3 over x minus 1 is bigger than or equal to 0. Now you've got to be careful. Remember, the square root of anything, okay, it only exists. What's under the square root sign has to be positive or naught. So straight away, I've got to deal with what's under the square root sign. So x minus 3 must be bigger than or equal to 0. So x, I can only accept answers that are bigger than or equal to 3. Okay, before I worry about whether I'm looking for negative or positive answers, okay, I say, where am I going to get answers that are bigger than or equal to 3? Okay, I can only put in x values into this thing, okay, if x is bigger than or equal to 3. Because if I put anything smaller than 3, this whole thing's going to be the square root of a negative number, which is non-real, and we're working in the real dimension. So immediately, okay, with a square root, okay, I would say the only region I can have is to the right of 3. Okay, so this region I exclude. I'm going to literally shade that in and say, remind myself, I can get no answers from anywhere to the left of 3. This region is excluded. Right, then I'll look at the sum. I say my other critical value. Okay, so when x is equal to 3, okay, I'm going to get a y value which is 0. Okay, but it can't have anything to the left of 3. The other critical value is at 1. Okay, and 1 is over here. Okay, so the answer to this question, and if x is bigger than 3, okay, so even you don't have to almost worry about this 1 in this case, because I can't have anything to the left of 3. This region is excluded because of that perfect square. Okay, so then I'm going to end up with anything bigger than 3, the top it will be positive, the top it will be positive, the bottom it will be positive, the whole thing will be positive, which is what we're looking for. Okay, so my solution is simply going to be, okay, I can have anything which is bigger than or equal to 3. There's my solution on the number line. So my answer is x has to be bigger than or equal to 3. Okay, and or you can say x goes from 3 to infinity. So remember the key idea. You get a question with a square root in, okay, what's under the square root has to be positive. Exclude immediately. First thing you're going to do is you say, what does x have to be? X has to be bigger than 3. You exclude that other region. That's taken out of the sum. What goes on there is just not possible, okay, because the whole thing will be non-real. All right, guys, I hope that makes sense. Okay. Okie let us stop recording. Okay, Stop recording. There we go. Stop.